Hello everyone, my name is Mete Atamel. I'm a developer advocate at Google based in London, and today I want to tell you about an app modernization story. So what is this app? Back in early 2016, a friend of mine and we wanted to build a news aggregator app. In this app, we would go and fetch news articles from various news sources, and we would display them in a mobile app in a clean timeline. My friend worked on the mobile front end, which was written in Ionic framework, while I worked on the back end. In this presentation, I want to tell you about the story of the back end over the years. Now, the back end was written in ASP.NET 4.6. It was a Windows app, and it was deployed on an IIS host. There were three main services: Reader to fetch the feeds from various sources, Transformer to transform them into a common format that we defined, and Web API to serve it to mobile frontend. We wrote the app over a couple of weekends, and it worked. And it was very easy to understand and deploy because everything was bundled together, and it was quite inexpensive to deploy to the IIS host. At the same time, the app had issues right from the beginning. First of all, there was too much coupling between services. Reader, Transformer, and the Web API, they were all bundled together. The developer experience of the IIS host was not great. Sometimes the machine that we were deployed on, it would go down. If we had to look at the logs of our application, we had to FTP into the machine and download them. Also, we didn't have any kind of redundancy, any kind of resilience, or any kind of persistence. So if there was any issues with any of the services, sometimes our app would go down. But this was a good start for the prototype, and we let it run for like a year or so. Now in 2017, after a year, we started looking into a better place for our application. That's when we started researching into Google Cloud. In Google Cloud, there is Compute Engine. It's basically a VM, a Linux or Windows-based VM that you can get and deploy anything you want. So we took our application and we deployed to a Windows server on Compute Engine. Once we deployed our application and configured it the way we liked, we created what's called an instance template out of it. And once we have the instance template, from there we created an instance group. Instance group is a load balanced set of virtual machines. With this setup, it was very easy to move our application because we didn't have to change any of our code. We just had to deploy it to Windows Server on Compute Engine. We got redundancy with instance groups, and we got load balancing with Cloud Load Balancer in front of instance groups. We also got the possibility of auto-scaling. In instance groups, you can actually specify metrics, and you can use those metrics to auto-scale if you wanted to. And the developer experience on Google Cloud was way better. We got integrated logging with Stackdriver. We got VM snapshots for backup and recovery. You could easily RDP into the machines. It was just a much better experience. At the same time, things were getting more expensive. Instead of running on a single machine shared by other applications, we were running on dedicated two virtual machines, and we were also using load balancing. It wasn't that much in terms of cost, but it was more than the IIS host. This model served us well for two more years. But between 2017 and 2019, there were a lot of things happening in the tech world, especially in .NET world. First, there was this new version of .NET called .NET Core. And one of the most interesting aspects of .NET Core is that it runs on multiple platforms: Linux, Mac, and Windows. Secondly, there was a lot of hype around containers. Everyone was talking about how to take a monolithic virtual machine-based application and how to break it down into smaller services and run them in containers, and how efficient this was. Third, we had this Windows dependency that limited our options on where to deploy our application. And fourth, the cost of our application, even though it wasn't too much, it was still considerable given that it was a hobby application. So all these forces came into play, and in early 2019, we started looking into how to containerize our application. But before we containerize our application, we had to rewrite it in .NET Core. We chose ASP.NET Core 2.2 to do the rewrite. That was the latest version at the time. And initially, we thought that this would take a couple of weeks because we didn't know what .NET Core provided, and we didn't know how easy or hard that would be to transform our application from .NET. But surprisingly, this was pretty straightforward, and it only took us one weekend. All the libraries that we needed in .NET Core, they were already there, and the main components of our application could remain the same between .NET and .NET Core. Now, once we did the rewrite, we freed ourselves from Windows, so we could start containerizing application. We containerized using Docker, and that was pretty straightforward as well, because there's all these base images that you can rely on to base your application on. And then once we had our application containerized, then we had multiple options on Google Cloud on where we can run the container. At the time, the choice was Google Kubernetes Engine or App Engine. Google Kubernetes Engine is a great platform to run more complicated, multiple services kind of applications. But in our case, App Engine Flex had everything that we needed. We just needed to run our container in an easy way, and that's what App Engine provided us. So that's what we chose instead of Google Kubernetes Engine. So with this setup, our Windows licensing fees were out, so we were already running quite a bit cheaper on Linux. We get hassle-free autoscaling with App Engine. In App Engine, you just get autoscaling for free, and you don't have to do anything special with your application. And we got nice features of App Engine, such as revision management and traffic splitting out of the box. But at the same time, we were still running on virtual machines. App Engine Flex does a great job of hiding the fact that you're running on VMs, but at the end of the day, that's where you're running, and then you have to pay for those VMs. This means that even though our application wasn't used a lot during the evenings, we were still paying those VMs as if everyone was using it. We also had issues with slow deployments of App Engine Flex. Sometimes it would take minutes to deploy our application. It wasn't a big issue, but it was something that slowed us down during development. Then in mid-2016, about 6 months into our containerization, something new came along called Cloud Run. And the whole premise of Cloud Run was to bring serverless to containers. This was very exciting for us because our application was already containerized, but we also wanted to get the benefits of serverless with fully managed services and with things like managed security, full auto-scaling, and serverless billing. Cloud Run promised all these features, but for containers. So this was something very interesting for us to explore. So and also the other benefits of Cloud Run is that it was very good for public endpoints, and it was also very good for internal endpoints that do some kind of internal job. Our application needed both because we had a public web API, and also it had some services that were internal. So it seemed like a good fit for Cloud Run. And the best thing of Cloud Run is its billing type. In Cloud Run, even though your container might be running for a while, you only pay for the requests. So you only pay for the time people actually use your application. This potentially could save us a lot of money because our application was mainly used during the day and not many people used it at night. So we could scale down to 0 at night and save quite a bit of money. So in mid-2019, we upgraded our application to the latest version of ASP.NET Core at the time, 3.0, and then we deployed to Cloud Run. This was a single gcloud command to run, to deploy to Cloud Run. It was very easy, and that's the beauty of containers. Once you containerize your application, deploying it to multiple platforms becomes much easier. And with this, we got serverless billing. We didn't have to pay for VMs at all times anymore. Instead, we only paid for when people actually use our application. And this made a huge difference for our billing. Secondly, the developer experience of Cloud Run was even better. The deployments were fast. You could deploy your application within seconds. And then we had features like integrated logging, revision management, traffic management, and all the other good features of Cloud Run that made managing our application much easier. But at the same time, we were still running a single monolithic application, and then we had those monolith issues. So these monolith issues, they were first of all scaling. We could only scale our application all at once. We couldn't scale individual services, and this was a problem for us because most of the time we didn't have to scale our reader or transformer. We only had to scale the web frontend with the number of users, but we couldn't do that. We had to scale everything together. Secondly, cold starts started becoming an issue. So when our application scaled down to 0 at night, it was great because we were saving money. But at the same time, when the first user came along, we had to wake up our container. We had to go and fetch the RSS feeds because we didn't have any kind of storage. Then we had to transform them, and then we had to serve it to the user. This made the first user wait for a while, and we didn't like that. Thirdly, all our state was in memory still. We needed to have some kind of state so that when the container came up, it could rely on the state that's been saved from before. And lastly, there was no way to update individual services. Most of the time, we didn't really need to update the reader, or we didn't have to update the web API. But we had to update the transformer quite a bit because all these RSS feeds, they changed quite a lot. So we had to update our rules. But there was no way to update individual services, and it was much riskier to update the whole application when we had to change a small part of our application. So with these issues in mind, in early 2020, the beginning of this year, we started looking into how to break down monolith into smaller microservices. And in the end, this is the architecture that we came up with. First, we created a new service called Reader. This is a private cloud run service, so it doesn't have a public endpoint, that would simply go and fetch RSS feeds. That's all it does. We put this in front of a Cloud Scheduler. Cloud Scheduler is a cloud-based scheduling tool, and it would call Reader every hour to go and fetch the RSS feeds. Once the feeds are fetched, they are saved into cloud storage, which is a cloud-based object storage solution. Once the RSS feeds are saved into cloud storage, you can configure cloud storage to emit notifications to a cloud pops up topic. So when a file is saved, it sends a message to cloud pops up topic, and then that would be pushed to another cloud run service called Converter. This Converter, it's another cloud run service, it's a private service, and it would receive the JSON RSS feed for the JSON, and it would transform it into a common format with the rules that we defined. Once the transformation is done, it would save into Cloud Firestore, which is a managed NoSQL database. It's perfect for JSON-like data, and it's also fully managed, meaning we don't have to maintain anything ourselves. And then the third service that we had was the web frontend. This was a public cloud run service with a public endpoint. And then the mobile frontend will call the web cloud run service, and then the web cloud run service would go and fetch the latest data from Cloud Firestore. As you can see, we broke down a single monolithic application into 3 different services. Some of them are private, some of them are public. They are totally independent from each other. So the reader, all it cares is the RSS feeds and where to save them. The converter, all it cares is the storage events that it gets from cloud storage and where to save the transformed RSS feeds, in this case Cloud Firestore. And the web frontend, all it cares is the data, the latest data in Cloud Firestore. Since they're totally independent, they can be scaled independently. So usually we scale the web cloud run if we have more users, but we don't really need to scale the reader or the converter because we don't need to do anything faster. And also, each service can be independently updated. For example, the reader doesn't really change because we don't have to change the way we read. The web frontend is very stable because it just looks at the Cloud Firestore, and the web API itself is quite stable. But the converter it needs to change quite a bit because these RSS feeds, they change a lot and we need to change the rules on how we transform them. In this model, we can easily update converter without having to touch all these other services. So all the issues that we talked about before in terms of the monolith issues, we could handle it in this setup. All right, so the lessons that we learned in this transformation journey. First of all, transformation, it doesn't have to be all or nothing. It's a journey. In our case, it happened over the years, and it's a step-by-step process where you go from one architecture to another architecture to get to the point where it's the optimal architecture. In our case, we were running on as a single monolith on a Windows server, and going from there to a totally independent microservices, event-driven kind of architecture on Cloud Run, it wasn't possible because the technology wasn't there. And then doing that switch in a big way, it's also quite hard. But doing it in a step-by-step way, it enabled us to actually make that journey. So just keep that in mind, the transformation, it doesn't have to be all or nothing. Secondly, as you do your journey, you're going to have non-optimal solutions along the way. For example, in our case, when you look at it, App Engine Flex was non-optimal. What we needed was Cloud Run, because Cloud Run really enabled us to have serverless billing, but it also enabled us to have event-driven microservices architecture. But at the time, there was no Cloud Run, so we had to deploy to App Engine Flex. But by having to deploy to App Engine Flex, we did the transformation from .NET to .NET Core and from Windows to Linux. So even though it was not optimal, it did help us as a stepping stone to more optimal solution, which is Cloud Run in this case. And sometimes doing something simple like lifting and shifting your application from IaaS host to cloud can have huge benefits. In our lift and shift, we didn't have to change our code. All we had to do was change our deployment from IaaS host to Google Cloud. But with that, we get instance templates and instance groups and load balancing and resilience and redundancy without really having to change our code. So it doesn't always have to be a complete rewrite to take advantage of new environments. But at some point, if you truly want to take advantage of the environment that you're in, you need to do some kind of rewrite. For example, in our case, our application was a monolith for a long time, and we kept it that way. But to fully take advantage of Cloud Run serverless billing and Cloud Run event-driven architectures, we really had to break down our monolith into smaller services, and we had to make them event-driven. And that meant that we had to restructure our code and we had to rewrite our code to be more event-driven. It took a lot of time and effort, but in the end it was worth it. And it's something that you need to keep in mind. If you are totally changing your environment, and in this new environment there's a new paradigm, you will need to think in a different way, and you will need to change your code in that way. And finally, you have to remember monolith decomposition. Everyone talks about how to take a single monolith and break it down into smaller microservices. It's usually a good idea, but you should keep in mind that it takes a lot of time and effort to do it right, especially if your application wasn't written in a modular way. You have to first get your application to be modular, then you have to break it down into microservices, then you have to figure out how those microservices will communicate with each other, and you need to figure out your CI/CD pipeline story. So there's a lot of things that you need to figure out once you break a single thing into multiple things. And the management of those multiple microservices is going to be harder as well. So you need to make sure that you have instrumentation and also monitoring in place as well. So when you embark on this journey, don't do it just because everyone tells you to do so. Do it because you have a really good reason. In our case, the really good reason was the serverless aspect of Cloud Run that made the whole thing worthwhile. But monolith decomposition is hard, and make sure you approach it with a good reason, and you also anticipate that it's going to be difficult. All right. Well, this concludes my talk. Hopefully, this was a useful journey for you and you learned something along the way. If you want to read more about it, I already blogged about this on my blog in a blog series with more details, so feel free to check it out. I also have the backend code on my GitHub under Amathus. And then if you're interested in Cloud Run, I also have a Cloud Run tutorial on GitHub as well. Feel free to check that out as well. Thanks very much for listening and enjoy the rest of the talks.